Good day, my dear grade 7 students. So how are you today? I'm hoping that all of you are doing fine and safe at home. So for now, we're going to discuss about the measures of variability. So the measures of central tendency show the value at the center of the distribution. Such information is inadequate to describe the characteristics of a set of data. The measures of variability are sometimes called the measures of dispersion, describe how varied, clustered, and dispersed the observations are in a given set of data. Okay class, so let us consider the two sets of data wherein we have in set A, we have 80, 81, 83, 84, 84, 85, 87, 88. Now let's find for the mean. So we says that when we say mean, that is the average. Okay, average. So if we are going to add 80, 81, 83, 84, 84, 85, 87, 88 to be divided by 8, so we are going to have a mean of 84. And then let us have the median. So when we say median, that is the midpoint or the midpoint value. So in this case, wherein we arrange this from the lowest value to the largest value, so the midpoint here is 84. So we have here now 84. Then let us have the mode. So when we say mode, that is the most common term used. So as you would notice, we use 84 twice. So meaning to say, our mode here is 84. Now let's consider the set B. So we are going to have the given, or we have the given 75, 77, 79, 84, 84, 88, 90, and 95. So let's have the mean. So if we're going to add 75, 77, 79, 84, 84, 88, 90, 95, divide this by 8. So we have here now 84 as our mean. And then of course our median here. So as you would notice, our median is this 2. So 84 and 84. So to be divided by 2, so you have 84. And then of course our mode is also 84. So that will be our mean, median, and of course our mode. The corresponding measures of central tendency in sets A and set B are equal, and yet the two sets are different. We present the data using number lines with arrowheads positioned at the lowest and highest observations to see how different they are. In the number line below, as you would notice in this video, the values in A are clustered between two neighboring arrowheads. The values in set B are scattered between two distant arrowheads. The values in A differ slightly. The values in B differ greatly. So the measures of variability will help us understand these differences. Let us have first the range. So the range is the simplest measure of dispersion. It is the difference between the highest and lowest observations in a given set of data. It describes only the arithmetical spread of the observations in the entire data. If we're going to find for the range, so we're going to use the formula highest value or H minus the lowest value or L. So using our given, so let's find for the range of our set A and for the range of our set B. Let us have set A to find for the range. So set A consists of this given data. So let's find for the range wherein we're going to use the formula highest value minus the lowest value. So our highest value here is 88 minus our lowest value is 80. So let's subtract. So 88 minus 80. So we have here 8. So meaning to say the range in set A is 8. Next, let us have set B, wherein these are the given set of data. Let's find for the range. So the highest value here is 95 minus the lowest value, which is 75. So subtract this. So we have here 20 as our range in set B. Okay, let us have the mean deviation. The mean deviation refers to the average of the absolute value of the differences of the observations from the mean. Note that all observations are included in determining the mean deviation. Hence, this is more reliable than the range. So let us have the mean deviation for the ungrouped data. This is the formula for finding for the mean deviation, wherein we have the summation between the difference of the value or the score of the distribution, and of course, we have the mean of the distribution to be divided by the number of observation. So we're going to use this formula in finding for the mean deviation. In finding for the mean deviation, so we have here the steps to follow. The first one is arrange the values according to the magnitude. Number 2 is you're going to solve for the mean. Third is find the deviation. Then get the absolute values of the deviations in step 3. And number 5, find the sum of the absolute values in step 4. And number 6, divide the sum of the absolute values by the total number of observations. Example, find the mean deviation of the given data wherein we have the set B. Given data are 75, 77, 79, 84, 84, 88, 90, and 95. So the first thing that you're going to do is to arrange the values according to magnitude. So these are the scores, so you need to arrange these from the smallest value up to the largest value. Second step is you need to solve for the mean. So in finding for the mean, so we need to add 75, 77, 79, 84, 84, 88, 90, and 95. And of course, you all know that the summation of our x is equivalent into 672. And then, of course, after that, you need to find for the mean. So use the formula. Mean is equals into the summation of our x all over our n, or the sample size, or the number of your observations. So we have here 672 to be divided by 8. So 672 divided by 8, so we have here 84 as our mean. So this will be our mean. Okay, class, so after you solve for the mean, let's have the step 3, find the deviation. So in finding for the deviation, so let's subtract the given value into the given mean or the mean that you obtain. So you have here 75 minus 84, so we have here negative 9. Then 77 minus 84, so you have negative 7, applying the rule of sign. 79 minus 84, so you have negative 5. Then 84 minus 84, so you have 0. 84 minus 84, so you have 0. 88 minus 84, so you have 4. Then so we have 90 minus 84, so we all know that is equivalent into 6. Then 95 minus 84, so we have here 11. Then get the summation of this value. So negative 9, negative 7, negative 5, 0, 0, positive 4, positive 6, positive 11. So that is equivalent into 0. So take note, class, wherein the sum of the deviations is equals into 0. So this is a great way to check your work into proceeding the step 4, wherein we need to get the values of the deviation in the step 3. Okay, class, for step 5, find the sum of the absolute values of the deviation in step 4. So we need to get the absolute value of negative 9 first, wherein we have here 9. Then the absolute value of negative 7, which is 7. Absolute value of negative 5, so we have positive 5, 0, 0, 0, then 4, we have here 6, and then we have here 11. And then afterwards, you are going to get the summation of this given, or the absolute value of our x, and of course our mean, wherein if we're going to add this, so this is equivalent into 42. So that will be our summation. And for the 5th step, we need to find the sum. After that, we are going to divide the sum of the absolute values of the deviation by the number of our observation. So therefore, in finding for the mean deviation, so we have here the sum as 42 to be divided by the total number of the sample or the total number of observation, which is 8. So 42 divide it by 8, so we have 5.25. So therefore, the mean deviation of our given set of data is equivalent into 5.25. Class, so let us have another example. Let's find the range and the mean deviation of this given data: 70, 71, 72, 73, 74, 75, 76, 77, and 78. Of course, so you need first to find for the range. So in finding for the range, use the formula. Range is equals into the highest value minus the lowest value, wherein the highest value here is 78 minus 70. So we have here 8 as our range. So therefore, this will be the range of this given. Okay, now class, let us have the mean deviation. But of course, please arrange first your scores according to magnitude. So we have here 70, 71, 72, 73, 74, 75, 76, 77, 78. And then first, you need to find for the mean. So you need to add first the score. And of course, if you're going to add this, so this is equivalent into 666. And then find for the mean using the formula. Mean is equals into the summation of our x to be divided by n. So the summation of our x is equivalent into 666. This will be divided by n, which is 9. So therefore, our mean here is equivalent into 74. So this will be our mean. Okay, after you find for the mean, let us have the second column table wherein you are going to find the difference between your observation and your mean. So you have here 70 minus 74, so we all know that is equivalent into negative 4. And then we have 71 minus 71 minus 74, so we have here equivalent to negative 3. And then 72 minus 74, so we have here negative 2. 73 minus 74 is negative 1. 74 minus 74, that is 0. And then of course, we are going to have 75 minus 74, we have 1. 76 minus 74, we have 2. 77 minus 74, we have 3. 78 minus 74, so we have 4. And then get the summation of this column, wherein we are going to have the equivalent of 0. And then after that, we're going to proceed into the next step in finding for the absolute value of your second column. So we need to get the absolute value of this given. So of course, we are going to have the absolute value of negative 4 is 4, absolute value of negative 3 is 3, absolute value of negative 2 is 2. We also have here 1 and then 0, 1, 2, 3, and then 4. And then after that, you are going to get the summation of the absolute value. So all in all, that is equivalent into 20. So we have here 20. And then after that, you can proceed now in finding for the mean deviation using the formula summation of the absolute value of your observation and minus the mean all over your sample size or the total number of your observations. So all in all, we have here 20 to be divided by 9. So we have here 2.22. So therefore, our mean deviation is equivalent to 2.22. So in this given, so the range is equivalent to 8. And of course, your mean deviation is equals into 2.22. Okay, class, so that is how you are going to find for the range and of course the mean deviation of a group data. So if you do have question, so please do not hesitate to ask your teacher. So again, thank you for listening and God bless everyone. Stay safe.